Hi everybody. Today's lesson we're going to be talking about some of the contributions of Charles Darwin in the theory of evolution. He's just like Gregor Mendel's the father of genetics, that pea plant breeding monk. Charles Darwin is considered to be the father of evolution. Early in 1800s, Darwin set sail across the world on a ship. And this ship stopped at many different continents, many different places, and he made a few important observations before he really developed his theories of evolution. One of his earlier observations was that in similar environments, you had organisms that shared similar characteristics. For example, if you found yourself in Africa on a grassland, you would see these large flightless birds called ostriches running around. Now, if you sailed off and went to Australia, you would find similar grasslands in Australia. And you would find similar large flightless birds. But these flightless birds weren't the same from Africa. They weren't the ostriches, they were emus. Right? They were similar, but they were different. If you were to travel to South America, again, they have grasslands, but they have a different large flightless bird as well. They have something called the rhea. Right? So, when you have similar environments, you also had organisms that shared similar characteristics. All around the world there's deserts, and in all of these deserts they have cacti. Right? But these cactuses are different in each desert that you go visit. The second observation that Darwin made on his trip around the world was that organisms always seem well suited for their environment. One of his famous stops was the Galapagos Islands, right? This small little island chain. But what's unique about the Galapagos is that even though all these islands are very close together, each island has a pretty different and distinct environment. However, the animals that you found in these environments always seem to match their habitat. For example, right, there is these large tortoises on many of the islands. And here, the tortoise on Isabella Island had this really low-lying shell right here, and this short neck. Right? This is a tortoise that's designed to eat the grass that was covering Isabella Island. Now, if you traveled a short distance to a different island in the Galapagos, you might find yourself on Hood Island. And Hood Island has no low-lying grass to eat. So the tortoises here have a much longer neck and this bump in the shell so that they can reach up and grab vegetation that's higher up off of the ground, since there is no grass on Hood Island. So again, the animals always seem perfectly suited for their environment. Darwin's last observation was that ancient organisms that were discovered, like through fossils, always seem to resemble modern organisms that are currently living today. Right? So fossils just defined as the preserved remains or traces of ancient organisms. And by studying fossils, we can figure out or infer what organisms kind of looked like in the past. So here we have two skeletons of human ancestors. All right. So the one we see on the left is something called an Australopithecus, which lived 2.5 million years ago. And then this is a skeleton of a Neanderthal, a closer relative to modern humans that lived about 30,000 years ago. Right? So if we look at the Australopithecus, it's like, why did they go extinct? When you compare that to the Neanderthal or even, a modern human skeleton, right? And we can see that, maybe they were too small to survive, right? The Neanderthals and even modern humans are much larger than what the Australopithecus was, right? If we look, even though it has a short body, right, look how long its arms are. And here, the arms only have a single bone, whereas in the more modern human, they have two arm bones. So maybe their limbs were just too fragile to support the body, and they were constantly breaking off arms and legs, right? We have all these reasons why this organism may have not survived and gone extinct, 2.5 million years ago, right? So by studying these ancient organisms, these fossils, we can infer, what caused them to go extinct and how they changed over time. Alright guys, that's it for today's lesson. Thank you.